In this video, we will discuss about edge dislocation or two-dimensional, one-dimensional defect, 1D defect. Let us see why this is called one-dimensional defect. For this, let us first consider a plane of atoms. A different, so several. This is a crystal. You can see that uh, this corresponds to different plane of atoms. That means you can extend like this. These are all different planes of atoms. So in this plane, so all these one line corresponds to one plane of atoms. And in this, I am deleting one plane of atoms. See, I am deleting this half plane of atoms. Oh, so let us see what happens. If you delete that half plane, see, you will get a half plane of atoms here. So this one half plane here is missing. So this is called the missing half plane. Okay, this is what happens. But this as such is not stable because the distance between here these two atoms is, so here it is, if it is A, then here it will be 2A. Okay, so there will be attraction between these atoms. Okay, and this will try to join together. So what happens next is like this. So the bottom atoms try to join together. Okay. So if you look from the bottom or the bottom side, you can see that there is no defect here. And if you look at the top portion, you can see that there is no defect. So that means, so that means if you look at only this portion, you can see that you cannot find any missing half plane. Okay, you cannot find there is an extra half plane. Similarly, if you look below this line, you can see that there is no missing half plane. Okay, so what you can find is that there is a missing half plane here only, right? So the top portion doesn't have an extra half plane, and bottom half does not seem to have a missing half plane. You can find a defect only near to this. Okay, so that's why you can see that there is a defect only here. Where you can find a defect only here. So, so you can find a defect only here. Okay, this is where the defect concentrate. So that means the defect occurs at the bottom of extra half plane, or that is at the edge of plane. So we will call this defect edge dislocation. So this is called edge dislocation. Okay. So see, this is called a line defect because if I draw a line like this, so this is a half plane. Okay. This is the total length, and here you can see that this here there is some atom defect. So this is only the lattice length is very small. So if you take this as D is very much smaller than L. So that's why we will take this as a line defect. You can see that, see, there is a cylindrical portion is missing, but since L is greater than this length, very much greater than D, we will take this as a line defect. So that is why this is called a edge dislocation because the atoms are missing from the edge of that extra half plane. Okay. So in this picture, I have drawn this. So you can see that, see, this is your half plane, and the missing area is this one. So you can draw this as a line. That means into the paper that plane of atoms is missing. So only the bottom edge of the half plane is defect, not the entire half plane. That is important point to note because the upper portion does not have an extra half plane and bottom portion does not have a missing half plane. The missing plane is only concentrated around the edge of the half plane. So defect is only that is why this is called a edge dislocation line. So this is the one-dimensional defect.